Hi, Tobias here, machine learner, scientist and software engineer at Schäuffelhut-Berger. Today I want to give you an introduction to Firetail's video synchronization module that can help you to enrich predicted behavior of wild animals with visual evidence. Certainly, documenting animal behavior by sketches, photography, or video data is in fact as old as the underlying technology. Notably, with few exemptions, most modern tags and colors will capture a wide range of sensor data without visually observing the subject. In this sense, combining visual footage with abstract sensor outcomes seems like a natural choice to help data interpretation despite significant challenges in a wild animal setting. One of the reasons why it is now routinely possible to detect species from camera trap data is the availability and the abundance of the required training data in terms of photographic evidence along with precise descriptions of what can be seen in it. For tag sensors like accelerometers or IMUs, the basic situation is quite different. Few people will visually inspect multi-axial sensor patterns and just assign associated behavior. Does that mean that after countless hours of calibration, traveling, field work and data collection, we finally have a decent amount of tracking data at hand, enriched with neat sensor data, but cannot ultimately use it to derive behavior? But fortunately, that's not the case. Tools like Firesum and other great applications can help us to derive behavioral categories from raw acceleration segments without the need to completely understand the underlying patterns in detail. In this regard, video sequences can provide an extrinsic way of assessment. Firetail's video sync module was built to show video sequences, location data and sensor events side by side. First, I will load a short sequence of acceleration data. For this tutorial, I don't use actual wild animal data, but for NDA reasons I'll work with data captured by my smartphone on a short trip by bike. I used the Open Camera Sensors app to capture synchronized acceleration data. Notably, the acceleration timestamps are based on nanoseconds since the last phone reboot and are therefore out of sync with the video sequence timestamp. This is something we can rectify using the Firetail's video sync module as well. Start the module by opening it from the main menu. Data, Sync Video Data. When first starting the video module, you'll be asked to select the MPV player binary. Navigate to the first party builds on the MPV website, mpv.io, and select the download for your platform, for example Windows, and then choose the zip file ending in -mscv. Unzip the download to a location of your choice and then switch to the video sync module and select the MPV binary when requested, or use the button in the lower left of the video sync view. On Windows, this is typically mpv.exe. Firetail will connect the MPV when a video replay is triggered or when connect is pressed. Now let's load the actual video data. When we select the footage from the hard drive, Firetail will try to detect the recording timestamps and durations of the resources. This video is some 2 minutes 49 long. The first thing I do is adding a short note on what this data is by editing the notes column. Notably, this resource included a UTC timestamp. To correct for systematic offsets, we can use the UTC plus and minus controls on hours, minutes and so on, and this will be applied to a resource during import. Let me demonstrate this. So I'll start by removing this video temporarily. This is done by using Ctrl left mouse click. Then I adjust the offset to UTC plus 2 and then press load video audio and select the same resource one more time. The resource is now set to start 2 hours earlier to match UTC time. To cope with systematic offsets, you can shift by minutes and seconds as well. We have several options to adjust the UTC video start. The simplest way may be to just double-click it and edit the timestamp. I will adjust the start hour to 11, undoing the demo UTC adjustments I did a few moments ago. Entering faulty timestamps will highlight the cell, then revert to the last working timestamp. Notably, the video timestamp does still deviate from the data timestamp. the creation timestamp embedded in this sample video is 11:18. This is a few milliseconds after the last timestamp of the sensor data. That means my mobile phone app seemingly buffered the video while capturing sensor data and created it once this was complete. Luckily, this is easy to correct for. I know the video footage and data start simultaneously and should be in sync then. In the main timeline, let me navigate to the first available timestamp, that is, the start of the data. This is 11:15, 15 seconds and 600 milliseconds. I can select the resource and use the current timestamp from the main timeline by pressing as selection start. Both data and video now have the same start, and let's replay it by double-clicking the resource path. It's also possible to rapidly do fine adjustments. I can move the mouse over timestamp in the list, hold Ctrl and Shift and use the mouse wheel to fine adjust the start timestamp in steps of 10 seconds. Or I can use Shift and mouse wheel to adjust in steps of 200 milliseconds. To reset my changes, I simply copy the timestamp again by pressing as selection start. Now both timestamps are identical. Of course, this mechanism can be used to shift the recorded data to whatever start will best fit the acceleration and sensor data. There are some cases where the only way to synchronize video and data is by identifying simultaneous events or events that have been introduced on purpose. In my example, let's corrupt the data and introduce an arbitrary offset by setting the start of the video to just some timestamp. We navigate somewhere here and assign this as start timestamp. Now I know that some 13 seconds into the video there I took some distinctive bend that should also be visible in the data. Therefore, first let's replay the video. I'll pause when the curve is visible. This is my video event. I want Firetail to remember it and press video event. Now I switch to the data view and zoom in a bit. The curve is nicely visible here as well. I select the start of this event by double-clicking the acceleration data. I can assign this as data event by pressing data event in the video sync module. Now let's hover the shift selection button. The help text will tell us the offset among data and video event. Finally, we can apply this offset by selecting the video and pressing shift selection. Let's replay both data and video in sync and see if this worked. You see, the video is now nicely in sync with the data. For my dataset, I've previously created some annotations to the acceleration data with Firestone. Now that my video is in sync, I have a nice gold standard to examine if key events in my prediction are correct. Let's navigate to another peak in the data and double-click it. The video does not automatically update the view. That's because the main timeline scale is typically orders of magnitude longer than the video evidence, and scrubbing the main timeline would simply not help to sensibly navigate the video. But we can query if the current timestamp exists in one of our videos. Let's press Query Resources. We see that the timestamp was found in this video and the player will show the associated position. In this case, the bike hit some rough ground that led to this peak, which is also in agreement with the annotation at this point. Until now, I only had one video in my resources, which is likely not always what you'll see in practice. Some projects or camera setups produce shorter clips that have to be synchronized. For this tutorial, I've cut the sample footage into shorter snippets of 30 seconds length. Let's clear the existing list with Clear List and then open the modified data. Now, these clips have the aforementioned systematic offset. Well, how to fix this? Again, I know that the first video starts when the data starts. I could use the UTC offset to fix this, but it's rather cumbersome to calculate the offset by hand. So notably, I cannot simply copy the timestamp from the data, as the assigned start is after the end date. So how to proceed then? The solution is to use the event mechanism. I can first copy the start timestamp of the first video up here. This is our video event, so let's mark it. Press video event. And then in the main timeline, I choose the first timestamp and then assign it as data event. Firetail has now computed the offset of both timestamps, and conveniently we can apply it to all our videos at once, that is, shift them by the same interval. I select all my resources using Shift Select and then press Shift Selection and confirm my choice. That's it. Each video is now in sync with the main timeline. To quickly save this mapping of resources to the data, simply press Quick Save. To save the mapping to a custom file name, use Save Video Mapping. Loading is straightforward, and it will add all resources in the file to the current list. That's all for today. I hope you enjoyed this tutorial. Don't forget to like and subscribe this channel. Stay curious, and thanks for watching.